As Paige mentioned, I'm Josh Mack, and I put a little bit about my bio up here just to kind of put it together so people kind of understand my background. So I started my career working for Iowa State University. I was there for about 10 years, and while I was there, I became the director of IT for the vet school. And the vet school, like other hospitals, has medical technology that you would find in any human hospital. So we had an MRI, a CT, and ultrasound machines. But what made us different is we would have a much larger. So if you've ever had an MRI, you've been in that little tube. Ours was about 3 times the size of that. So you could fit, a horse or a cow or a large animal through that. And so we got to deal with electronic medical records, PACS systems, and all kinds of electronic technology that revolves around the medical field. Then I went to work for the Minnesota State Senate. I was there for about 2 years. I was the director of IT. So I got to oversee an initiative going on at the Minnesota Capitol, which was $250 million in renovation. And I was the lead person making technology decisions for wired and wireless, door security, camera security, standards of cables, and all kinds of infrastructure decisions. Then I was hired by North Iowa Area Community College in Mason City. I was the chief information officer there for 6 years. In 2018, we deployed Aruba Wireless, and in 2021, we deployed Aruba Wired. In 2017, while working at NIAC, I was elected to the local school board, and then I was reelected in 2021. So I'm in my 7th year being a school board member. I was fortunate enough to be president of the school board for 2 years during the pandemic, which was a really unique and interesting time to be on a school board. And then in 2022, I was hired by Sterling Computers out of North Sioux City. They're a local partner that specializes in technology sales. And then in 2023, I was hired by Aruba. And so coming over to Aruba, I got to learn a little bit about things I wasn't familiar with. So if you know Aruba, you know that they've been a leader in the Gartner Magic Quadrant for the last 18 consecutive Gartner Magic Quadrants. And so if you look at the top right, which is kind of where you always want to be, there's two players up there, Juniper and Aruba. And as everybody knows, we are acquiring Juniper, and that acquisition will hopefully happen sometime in the next, year. And so once we bring that in, we'll have the #1 and the #2 spot in the wired and wireless technology. Aruba's portfolio is really kind of unique. As people thought about us as a hardware company, we started to transition to not only being a hardware company, but also as a security company. So if you kind of look at this diagram in the middle, it kind of shows the products and services that Aruba has to offer. And then we're kind of bookend on each side by kind of where you want to go and kind of who's going to be accessing it. And what we're going to talk about today specifically is our SASE portfolio. So the Secure Access Service Edge. So Gartner coined that term in about 2018. And the idea is it encompasses 2 products about how to secure the edge of your network. And so the first one is Edge Connect or SD-WAN, which is really around software-defined networks, connecting branch and remote sites using commodity-based internet, managing through software instead of dedicated fiber or MPLS circuits. For us, that's a product called Silver Peak. The other side of that coin is SSE or Secure Service Edge, which is a newer technology, and it really is around controlling access to applications. How do people access your applications, and then how do you secure that access to them? So that's what we're going to talk a little bit about today. Excuse me. And so this is kind of the different product segment within the SASE portfolio. So on the left-hand side, we see our SD-WAN, our Edge Connect. We have routing, dynamic path segmentation, WAN optimization, and then SaaS acceleration. So we have a unique place in the market where we can basically take applications and do it at the application layer and give them an accelerated path to a cloud or a SaaS provider. And then we also can do network as a service. So if you say, hey, I don't want to manage my network anymore, I want to offload that, we can help manage and do that. And then the other side of that is our Secure Service Edge or SSE. And that encompasses a bunch of different things. ZTNA, which is a popular term now, or Zero Trust Network Access, is designed around securing that tunneled connection between the application and the end user. And then we have CASB, or the Cloud Access Security Broker, designed around what can you do when accessing a cloud application, controlling upload and download and who can access and where you can access it. A really good use case for that is we have a customer in Michigan, and they're a higher education institution. And they had all of these people downloading data out of their ERP system, then taking that data and uploading it into cloud services that they didn't manage. They were an Office 365 shop, but they would have people exporting data and putting it into Dropbox or Box or some other third-party cloud app. So they said, we're going to collapse that. We're going to control where you can and cannot go and only allow you to upload data into OneDrive. That way they can manage it, control the access, and understand who and what is accessing that data. The next one that's part of the secure service edge is SWG, or Software Web Gateway, which is really around deciding what websites you can go to and how you can get to them. And then Firewall as a Service, which is a very common one people have heard of. RBI, which which looks like a baseball term, but is actually remote browser isolation. And then DLP, which is data layer protection. So if you have data that has data classification of secure or highly secure or public, we can look at that data and ensure that only the people who have the proper credentials and access are allowed to access that data. So let's talk about traditional ways people access applications. So traditional internet access would be something like this. So you have an outside person with a VPN tunnel. They go through the internet, and then they go and they hit your campus firewall. And that firewall makes a determination on whether they want to access an application that's behind the firewall, or if they want to go back out and access a cloud application. So if it's a cloud application, they're going to hairpin that traffic back out through the firewall, through the internet, and access that cloud application. So you have all these people on your network that don't need to be if they're accessing cloud applications. So you have a huge significant security risk. You also have a lot of complex management trying to figure out how to manage where people are going and how they're getting there and then what they actually should access. You also have to buy large firewalls and routers because you have all these people coming in and then all these people coming out. Each system is going to have a different layer of management, a different control, and a totally different interface. Another typical way that you may set up a VPN tunnel or an access to applications would be doing a split tunnel. Now, split tunnel is designed around saying at the endpoint, we're going to split that traffic. If it's a cloud app or internet traffic, we're going to just take them through the internet and allow that path to happen. If they need to access an application within our data center, we're going to route that through the VPN tunnel and into our firewall, and then ultimately to the application or resource within the network. So the concern is, and this happened at one of the places I worked before, we had an individual who we did split tunneling, was browsing the web, and they got a virus on their machine. And that virus then said, hey, I'm going to start looking for different technologies or network paths for me to access. And it found that VPN tunnel. And so now that VPN tunnel between the end user and the firewall says, hey, you're a trusted connection. I trust you because you've already validated who you are. So all the traffic that you're going between me, the firewall, and the end user is okay. And so that virus said, oh, hey, well, I have this great path. I'm going to go through this firewall, take the trusted path and the secure connection, get through, and now I'm in the data center. And so this virus found some enumerated shares, placed a file on those shares, and then walked away. And then what happened is a couple weeks later, someone saw that file and thought it was something else, double-clicked it to execute it. They got a weird error message, didn't think anything of it, went on their way. And then I got a call about a week after that from our chief financial officer. And she said, hey, I'm trying to run some reports with an Excel spreadsheet, but I got this weird error message and this pop-up page that says, I need to go to this website, which is this really weird onion website with this really long string behind it. And it says, I need to pay these Bitcoins. What had happened is someone had dropped a file behind. It had began an encryption process and encrypted all of our file shares. So we had to unencrypt all of that and redo it. Very time consuming, very expensive, and very frustrating. So as I mentioned, firewalls are difficult to manage. Firewalls and the VPN technology is difficult to see where people are coming from, how they're accessing it, because once they're on the network, you trust them. And so what we want to do is we want to help make that an easier way to manage and offload responsibility into technologies. So a lot of times that technology or that end user has to come to the firewall before determination can be made. Our solution is cloud-based first, so they can access it from anywhere in the world. One other story that I'd like to tell is when I was a CIO at NIAC, we were in the process of purchasing new firewalls. And so we were a Cisco shop when I originally got hired, and it was time to purchase new firewalls. So what we did is we went to the major manufacturers at the time, Cisco, Palo Alto, and Fortinet, and we asked them, hey, can you provide us a quote to purchase new firewalls? And so after reviewing them, we decided we were going to settle on Palo Alto. And so I started talking with the Palo Alto sales team about what we wanted to buy. And their question was, well, how big is your internet connection? And I said, well, we have a 1 gig internet connection. And they said, okay, well, you're going to need to buy a 5 gig firewall. And I said, well, why would I need a 5 gig firewall for a 1 gig connection? And the sales team said, well, once you turn on SSL decryption, file and web-based control, you want to know where people are coming from, you want to turn on VPN, all of these different services that you want is going to reduce that throughput from 5 gigabytes to 1.3 gigabytes. And so I had to overbuy my firewall in order to be able to get the data and information I wanted out of those connections. Our solution is different. What we want to do is we want to simplify access to applications. Excuse me. And so how do we do that? Well, the first thing is we offload everything into the cloud. So we use a cloud portal to manage connections and access. And so people only get on your network if they need access to an application that's behind the firewall. And so how do we do that? We use on-premise and cloud connectors. And those connectors are small little applications that run on port 443 UDP and do outbound traffic only. So you take your applications and you publish them to the connector, either on-premise or in the cloud, and then that publisher publishes it to your cloud portal, allowing your individual users to access it. And we can do it either client or clientless. So your users have one place to see all of their applications, and each time they launch an application, it does a secured tunneled connection between the application and the end user. So there's no east and west traffic on your data center. There's no kind of snooping around in the data center. They can't go anywhere else because there's no pathway for them to get there. They can only access the applications that you've published for them. We talked a little bit about this, which is the kind of the 4 tendencies of SSE or Secure Service Edge, ZTNA, which is that tunneled connection between the application and the end user, the software web gateway, which is designed around controlling access to applications where people can go on the internet. And then the third one is CASB, the Cloud Access Security Broker. I gave you the example of the higher education institution that wanted to control access within the cloud services. And then the digital monitoring experience, which watches the pathway between the end user and the application they're accessing and ensures that they get the best possible path between the application and the end user. So some of the use cases that you may want to understand on, what would I use this for? What's the value I'm going to get? Well, you get better control and management into your endpoints. You can replace legacy VPN that are difficult to manage, and you optimize it with cloud technology. So you may say, well, we have a technology that we use for web content and filtering. We have a different application and a different manufacturer we use for VPN access. And then maybe you have something else for application access, maybe a Citrix NetScaler or a VDI solution. You can collapse all of those technologies into one. We can do it agent or agentless. We focus on least privilege access. So instead of giving everybody access to everything, they only get access to what they need. They can't see other technologies or go other places because they have no pathway to get there. It's a great solution for things like HVAC contractors who say, hey, I'd like to put a VPN box on your network so that I can manage the interface for our HVAC systems. So they send you a VPN box, you put that VPN box, and then it's kind of a black hole. What happens there and what's going on is really difficult for you to understand. And so if you remember, it's been a couple of years, but Target was actually compromised through their HVAC contractor. So Target, a national retailer, has different contractors that manage their HVAC. Some of them are regional and local to the location they're at. Some of them are national. And so they had logins into a VPN within Target. So Target had said, we're going to segregate and separate all of that technology and all of that traffic into one VLAN and keep them separate. But the thing we always have to remember is they all roll up to that same switch. So even though it's in a different VLAN, the port next to it may be a port that has all their point of sale system, which is exactly what happened in this situation. that HVAC contractor's account and credentials got compromised. The attacker was able to get into the target network and then laterally move across the network, get into the point of sale system, and ultimately steal a bunch of credit card information from Target. With our solution, they wouldn't even have a pathway to get into the other network because they don't know it exists and there's no way to get there. With Swig, you can monitor and inspect all your traffic, so you can make sure that if people are going to websites, you can control what and where what they do on those. So, for example, if maybe you say you're a K-12 and you say, hey, we can go to YouTube, but this content or this creator are not allowed. They would be able to get to YouTube and see videos and watch things. But if it was from this creator or it had this content, it would automatically block them. We can also do a 7-layer application review. As that packet comes down through the connection to the end user, we inspect that to ensure things like, is the SSL correct? Is the website correct? Is there any malformed or malicious information in one of those packets? If so, we're going to separate that and segregate it from the traffic before it gets to the device to help protect that endpoint. And then you also get a uniform approach. So if they're on campus or remote or wherever, they're all going to have the same technology. So they'll all have one set of rules to manage. And then CASB allows you to protect sensitive data to ensure that only the people who have access should have access to it, and they can only do what you decide they can do in cloud services. A really good one for this is discovering shadow IT. We had a Michigan city where within the city, before the CIO came on board, there was the IT within the fire department, the IT within the police department, the IT department within the mayor's office. So she came on board and collapsed all of that and said, hey, if it's not in the access portal, we're not going to allow you to access it. So it helped her manage and control technology much better, because ultimately she was responsible if there was any issue, a breach, or data leak. They would come to her and ask her how they were going to solve it. So she said, in order for me to protect our systems, I need to be able to better control them. So, excuse me. So then you say, well, Josh, that's great. We love it. We talked a little bit about these. I think one thing I do really like to point out is that it's a very uniform approach for everyone. So if you have individuals who are on campus or remote, students, faculty and staff, janitorial staff, whatever they are, they're all going to experience and consume the technology in the same way. So from a support perspective, it's very easy for you to say, hey, I know how they're consuming it. I know how they're accessing it. So I can tell you what issues you might have because everybody does it in the same way. You don't have east and west traffic in the data center because they can't go east and west. They can only access the applications that you've given them access to. There's no pathway for them to access anything else. So, Josh, this is great. We really like it. How do we cover the cost of a technology like this, right? There's different ways, because one thing you can do is you can collapse instead of having a firewall and something to manage content filtering and maybe an application control, VPN, or excuse me, like a Citrix or remote desktop or a VDI. You can do all of that with one solution. That's where we would come in. You can reduce spend on one-off technologies, collapse them all into one easy to manage interface. As you look at cybersecurity, I know when I was a CIO, one of the things that came through a lot is the cybersecurity insurance company would come to us in May and say, hey, we want you to implement this technology for next year in order to, control costs for us as your insurer. And so if we said we didn't want to do that, they would say, that's okay, you don't have to. But instead of maybe a 3 or 4% escalation, you're going to see a 20% escalation because our risk is higher. One thing you can do is proactively say, hey, we are securing our applications, we're securing access to our network, and we're securing our technology by using the Aruba SASE solution. So people can't get to things that they shouldn't get to. They can't get things because they don't know how. There's no pathway for them to do that. So it helps the insurance company realize that you become more secure. If you don't have a portal or a place where all of your applications exist for people to be able to go access them, this is a great solution to do that. You can load up all of your applications in one place, and then end users can go and see those applications and access them very easily. And so we have about 4 minutes left. And so I want to make sure I leave some time for questions. So I'm going to kind of stop there and just ask if anybody has any questions or if anybody put anything in the chat. Appreciate your time today. Hopefully this was beneficial to understand kind of Aruba's security portfolio.